Hi everyone, I just wanted to apply the concepts we've been learning in class to the type of problem you will see on your midterm. And I guarantee you that you will see a problem exactly like this on a midterm that kind of synthesizes the concepts of resonance and hybridization, and you really have to think about where your lone pair is. So let's look at this. We have a molecule over here of histidine, and let's say Professor Hooley asks, what's the hybridization of each nitrogen atom in your histidine? Now, this is where using steric number and memorization completely fails you. Because you could say that, OK, I have a lone pair and 1, 2, 3 sigma bonds. That gives me a steric number of 4. This is sp3. Same here, lone pair, 3 sigma bonds, steric number of 4. Maybe it's sp3. And in this case, that answer would be wrong. And we'll take a look at why. So, in the case of this nitrogen atom, you have a lone pair and 3 sigma bonds. But is it sp3 hybridized? Well, the question you then have to ask yourself is, does the lone pair participate in resonance? Or what type of orbital is the lone pair in? In this case, this lone pair can't participate in any resonance because we have carbon atoms that have hydrogens sticking off on here. Doing anything with this lone pair would violate an octet rule for this carbon. So we can say that this nitrogen is indeed sp3 hybridized, and the lone pair is in an sp3 orbital, sp3 hybridized orbital. But now let's move to this nitrogen. Now, this nitrogen has the same kind of structure, it seems, as that one. We have a lone pair and 3 sigma bonds. But now we have to ask ourselves, does this lone pair participate in resonance? Or can it participate in resonance? And the answer here is yes, because we have a lone pair right next to a carbon that contains a double bond. So what you can do is take this lone pair, shoot it down to here, and move this double bond electron-rich region onto this nitrogen, giving us this structure right here. And let's assign formal charges. This nitrogen will now have a positive charge, and this nitrogen will now have a negative charge. So we saw that this lone pair on this nitrogen atom could participate in resonance, which means that the lone pair had to be in a p orbital. Again, this kind of goes back to what I said about thinking of resonance as a p orbital phenomena, where we have this conduit or this little highway of p orbitals. So we know that this nitrogen has to have a p orbital for its lone pair to participate in resonance. So the only answer we can come up with is that this nitrogen is not sp3 hybridized, and instead it must be sp2 hybridized, because we need that extra p orbital to have resonance. Now let's look at this nitrogen atom lastly. What is the hybridization of this nitrogen atom? And again, it had a lone pair over here in this electron density of the pi bond that participated in resonance. See, this lone pair was once a pi bond over here. So this nitrogen is also going to be sp2 hybridized. And again, there's a lot of practice midterm problems that Professor Hooley posted that have this kind of concept that you need to apply, where you have to think about where your lone pair is, does your lone pair participate in resonance, and then assign hybridization. And again, I guarantee this concept will show up on your midterm and potentially your final.